Twinkle, twinkle, little star, how I wonder what you are, what you're made of, why you shine. These are big questions of mine. What makes you appear so bright when far away is your source of light?
Stay tuned in and you will see. Come on, let's solve this mystery.
What are stars made of?
In space, there's big groups of dust and gas, primarily hydrogen. It is the most simple and most abundant element, just kind of floating around, minding its own business. This is called a nebula. Because of something called universal gravitation, the hydrogen atoms attract each other and more stuff accumulates and clumps together, resulting in a growing glob of mass. Once this reaches a certain size, it becomes a star. All to say, stars are mostly hydrogen isotopes: hydrogen, deuterium, and tritium.
So why do they shine?
This mass is so large
That the gravitational force pushes the hydrogen in the core of the star closer than normal conditions would allow. The repulsive electric forces between the positively charged nuclei are overcome by the immense force of the star's gravitational pull. Once the nuclei are within approximately 2.5 times 10 to the negative 15 meters of each other, the strong nuclear force takes over and the two nuclei fuse together to become one helium nucleus.
In reality, there's multiple reactions that take place, but this is the first step in any series of reactions. When nuclear fusion occurs, we observe that the mass of the daughter nucleus is actually less than the mass of its constituents. What?
Matter can't just disappear. Einstein said that mass and energy are related by this equation, and the law of conservation of energy states that energy can neither be created nor destroyed.
This means that matter is a form of energy, so we can take it into account and say that matter and energy as a system must be conserved. Think of this.
I put water in this plastic bag, then I seal the opening. Now I put the bag in the freezer. A few hours later, I take it out and there's some ice. You might say that ice was created and that because there's less liquid water, some of it was destroyed, but the total amount of water hasn't changed. It's just that some of it took on a different form.
And as ice and water can become the other, matter and energy can be converted into one another, and that's exactly what happens here.
The missing mass isn't vanishing, it's converted into energy in the form of photons, more precisely gamma rays. These high-energy electromagnetic waves are absorbed and re-emitted by atoms as they travel towards the surface of the star. Each time this happens, they lose a little bit of energy, and by the time they reach the surface and are able to leave the star, they've decayed to visible light. If it doesn't interact with anything, this light makes it all the way to the Earth, and that's the light we see made by the star.
This is what we see at night. It's what makes stars shine so bright.